Welcome to the session, guys. In this session, we are going to see the architecture part, multi-tenant architecture and non-multi-tenant architecture. What is mean by this, and what are all the things we are going to learn as part of this? Multi-tenant architecture introduced from the 12C onwards, 12C database version onwards. Before 12C, we are having or prior to the 12C, we are having so many versions, right? Oracle database version 1 to up to the 11G release, version 1 to 11G. So we don't have any kind of like multi-tenant architecture kind of one. They introduced from the 12C release onwards. Okay, and till now, whatever we saw as part of our course, we gone through the things traditional non-CDB architecture or non-multi-tenant, non-multi-tenant architecture. Till now, we saw this one. Till now. And now we are going to learn about this thing. Okay, and we will go through it high level history of these things. What exactly mean by this multi-tenant? As I said, from 12C onwards only Oracle introduced this multi-tenant architecture, and this multi-tenant architecture is nothing but the container CDB database and PDB database model. Okay, CDB means simple. C means container and P means pluggable. DB means database. Container database, pluggable database. Why they introduced these things? We can go through our traditional non-CDB architecture or non-multi-tenant architecture or non-container architecture, whatever it is. If somebody will say, do you have an experience on multi-tenant architecture, multi-tenant, or if they are asking you container architecture and CDB PDB model, do you have any experience on that? You can say simply yes. Okay, we'll go through that history. This is non-multi-tenant architecture, whatever we learn till now. Okay, it is simply the combination of our Oracle instance and the database. These are all our physical files, CRD files, password files, control file, redo log file, database file, and parameter files, parameter P file or SP file, or password file, and so on. All those files together we call it as a database. So here we don't have an option like CDB and PDB kind of one. It is like plain architecture, even though from Oracle starting version onwards, Oracle 7 or 1 to 7 or 7i, 8i, from 9i, and then 10G, 11G, all these versions we followed the same architecture. From 12C onwards, introduced multi-tenant, still we have an option to go with your this architecture, old architecture, old or non-CDB architecture, or new multi-tenant architecture. We have two options in 12C. Even though in 19C, we have two options. This architecture, old one, or new one. New one is multi-tenant architecture. From 21C onwards, 21C and 23C, these two are the latest version. This is for innovation version, not for the live like business use cases. But yeah, this is innovation version, but it is a long term, new long term. 19C is the our long term database. Till now we learn those things only, right? As part of this course also, we are going with the 19C. But as I said in earlier also, Oracle has been officially released. The 23C is our new long term version up to 2020, 2030 or close to 31st, mid of 31st. They are going to support this version. As of now, we are in 2024. This 19C is going to end 2027 June or July. Somewhere they are going to stop the support from 19C version. But Oracle has been introduced another one, 23C. From 21C onwards, we don't have old architecture. It's a mandatory. We have to go with multi-tenant architecture. 21C, 23C. We will not get any options like whether you want to go select with a non-CDB or CDB. No, there is no options. Okay, in one of our videos in YouTube channel, I placed this 21C installation. If you want, you can go through that one. Otherwise, I'll show you later also. That is not an issue. So up to 19C, we have two options. From 12C, they introduced a multi-tenant architecture, but 19C also, we have an option whether we want to go with the old architecture, whatever we followed instance and database. There is no CDB, PDB model. But if you want, you can go in 12C or 19C. Okay, that is a high level history of this. Now, this we already gone through it, right? What is non-CDB? We are having the individual things. If you want to install this database, like business is required. Okay, I have started my business, new business I started in 3 countries. So each country, I need different business like BUs. So I need 3 databases, 3 DBs to hold my 3 countries data. Individual country, one database. Like 3 countries, 3 databases I need. So in that case, what I need 3 servers. Okay, this I need US, India, and UAE. So I mean, I have started business in US, India, and UAE. So in these 3 countries, I'm going to start with 3 different servers. In this server, I'm going to store my US related database and US related users able to connect and they can do their activities. The same in India, I have built one new server. I have started my business same way. So in this way, what will happen? We require 3 servers and then we have installed the databases in 3 servers differently and we are managing. If you want to manage 3 database servers, we require resources. Suppose this database to apply the patches, to do the clone, to do the user management, to do the table space management, all we need to perform differently, individually. So resource consumption also is required. Resource as a DBS, like 1 or 2 DBS, we need to place it 1 or 2 DBS. In that case, if I want to expand my business, even the same countries, I want to go with from 3 to 30 databases. At that time, so 30 servers or 30 times I need to install the software and 30 times I need to configure my database. At that time, resources is required minimum to maintain these things. 4 to 5 DBAs are required. And the resource means CPU memory and the server memory storage and the server configurations they need to purchase, right? We need to purchase. I need to spend a lot of money to own this. And also if I want to maintain all these 30 servers, it requires huge resource in this scenario. To overcome this kind of achievement, I mean this kind of scenarios, even though we have an option, right? One server, 30 databases also you can install. But each database we need to configure the software. First we need to install 30 times software we need to install and then 30 databases we need to configure, even though you are going with a single server. That is also what I can say, to maintain 30 databases and single server, you require huge kind of ones, software, everything. Even we need to invest that much of this thing, licensing part also. How many databases are you are going to use? That much licensing you need to purchase. These are all the things which we did normally till now. But 12C onwards, Oracle has been introduced. Hey guys, why you are going to spend that much of amount and why you are going to put that much of resources? So we are going to introduce the multi-tenant architecture. We are going to introduce your multi-tenant architecture. This will save you financially. It will save you the resource kind of one. Like as of now, for your case, 30 servers is there. You are going to maintain like 4 to 5 DBAs and other OS team, storage team, all together you required huge resource. In case of servers also, you are going to purchase lot of servers. So we are going to introduce the multi-tenant architecture. By using this multi-tenant architecture, you can do lot of things easier. Maintenance is going to be very much easier And the cost wise also it is going to very much friendly, like less cost. And license one, you can take one license and make it huge difference. You can see the difference. They introduced this. We no need to go for this multi-tenant architecture too much. We already gone through it. We saw like what is instance and what is database and what is server, how the users are going to connect. Okay, now we are going to focusing on this multi-tenant architecture. In multi-tenant architecture, irrespective of non-multi-tenant, we have only this thing, instance plus database. But in case of multi-tenant, we are having this new structure. Instance also will be there. The same, whatever the instance we talk about in non-multi-tenant, this this portion, it is same here also. But whatever we are going to talk about this database portion in non-multi-tenant architecture, that is change it to this one. This complete portion we call it as a CDB container. Okay, here also we call it as this is container only, but we don't called in before 12c another thing, like 12c only they introduced it, right? Even though you are going to use or not, but we call it as a container. Okay, multi-tenant database, container database, or CDB PDB database all together same. But in multi-tenant single container database, you are having one CDB container database root will be there, and one PDB seed will be there, and one or more pluggable databases will be there, PDBs, one or more, or zero or more, you can say. If you want, you can configure only CDB database without pluggable databases. That is also possible. Okay, if you want to configure zero or more PDBs, you have to go with this multi-tenant architecture. We will see one by one. And also another kind of structure it is. Till now, whatever we gone through it, multi-tenant architecture is nothing but the CDB PDB model. But in case of this application container, if you want to create, we can create on CDB level on application container. That application container react or act as a root for all this application. Simple guys, one thing. I'll give you one diagram so that you can understand. Paint. Let me take. Okay. Where it is. Till now, whatever we saw in this server 1, S1, you can take this is server 2. This is server 3. This is non-multi-tenant. Okay, this is multi-tenant without application container apps. This one is multi-tenant with apps. This one without apps container. Till now, I haven't seen this thing. Very rarely a business is going to use this architecture. Most of the organizations are going to use till now this one or this one, any one of that. From 12c onwards, if the users are using, or client is using 12c or 19c, or later after 12c, they are going to following this one or this one, any one of that. But this one is very rarely I can see it. But I want to show you the difference. See, in case if I want to install 10 databases, 10 databases on this server, non-multi-tenant. So 10 times software I need to install, 10 databases I need to create on this server. If I want to apply a single patch, I need to apply the patch on all 10 software homes, all 10 homes individually. So each patch is taking 1 hour. 10 softwares I have, 10 databases I have installed in this server. So 1 into 10, okay, 10 hours I required downtime, or 10 hours it will take to apply a single patch. Same thing in this multi-tenant architecture. The architecture itself, it is CDB PDB model. CDB, PDB model. So single container, when you are going to install, you will configure 10 pluggable databases. Instead of installing 10 times software, we are going to install only one time software, and then we are going to create this CDB. If you apply the patch on this CDB container level, you no need to go for individual PDB level patches. We no need to apply. If in this case, if we are taking only 10 pluggable databases. So one patch, if you want to apply 1 hour, all 10 PDBs we can able to apply. Why? Because we are maintaining the software once. Once you install the software and you are configuring the container CDB and PDB thing. So one time we have installed the software. If you want to apply a patch, that software level you are going to apply it. If you want to shut down or if you want to maintain any maintenance activities, individually you can do it. Stop only one PDB and do the activity on this PDB related things, password change or other things. But in case of here in this server, even though you are going to maintain that, for this it is specifically we need to very precautiously which database is user is going to down and other things. And resource wise it is going to take huge. Like each database you are going to give 100 gig. 10 databases into 100, it's almost 1 TB, right? But each database is going to use 10% buffer memory or storage, anything you can take. 10 into 10, almost you are going to take 100 to 200 gig storage is going to waste in this case. But in case we are not going to waste anything. So resource wise, we can able to save the resource. We can add downtime also. We can able to maintain. If you want to do the clone, that is the best feature in multi-tenant architecture. In this scenario, if you want to do the clone, we have to do it individually, right? We have to take the backup of this and copy to new server, and then we need to restore that, and then we can do the lot of things. But here, just plug and unplug, or take the context or information of this pluggable database and copy to another server or same server. We can do it in a very minimal time. Minimal. Here, if it is taking like 10 hours, depends on your size of the database backup. But the same 10 hours, if you want to do the clone using multi-tenant architecture, CDB to PDB to PDB, it will take like within an hour, 1 hour. We can complete the clone. That much of flexibility. And one DBA can able to manage all these things. But here we require 3 to 4 DBAs to manage all these things. And also it is a very burden also, right? Single server you are going to, if something goes wrong, and so we can unable to make it all these things. But in case of earlier also, how they are going to manage 10 database into, they took 10 database servers and they are going to install each server. They are going to configure one database. That is also burden to the client. But in case we have so much of flexibility of introducing the multi-tenant architecture, and the same architecture, what they did is they have created one more in a CDB. As I said, we are going to use 0 or more, like more than 256 or pluggable databases we can able to create it more than 256. Okay, the same way they have introduced application container. The same CDB, we have an option to create application container. If you want to create separate pluggable databases and not under CDB, under application container database, you can create PDB databases related to this application container. This is very specific business related, guys. In the same company, if you are using multiple businesses, some you call it as some is a critical and some is non-critical, or these are non-critical databases, pluggable databases, and we are going to manage whatever the users are going to manage. Simply what I said is whatever the users you are going to create in a CDB level, that users we call it as a common users, right? Same way the business, it is required on application container level. If you create a new user, that application related content pluggable databases, they can able to access with that user. So it's a parent and child kind of tree, guys. So In CDB will be there. Inside of the CDB, we are going to create number of PDBs. The same way we can create application container on top of the CDB. This application container holds 0 to 256 of pluggable database. Again, this is one kind of parent and child operations. According to their business needs, they are going to follow. I haven't seen much this kind of architectures real time. I could see this kind of architecture. This is only one difference between application, multi-tenant without application, this one, without application container. Multi-tenant with application container is this one. These are all the three different types of architectures which we have. I'll show you in a diagram also, as I showed you. This is multi-tenant architecture. So complete. It is holds application root. We have two application containers. You can create n number of application containers on CDB. One application container, another one. This is our CDB root. In this CDB root, we created the application root. Each application we are creating two pluggables. It is a seed. And for this application root, we created 1, 2, 3 pluggable. Don't confuse anything, guys. It's a databases, individual databases. That's it. For all these things together, we call it as like control files and few SP file, server parameter file. These are commonly we are maintaining for all these things. Control file is single only. We are not going to maintain individual PDB control file. We are maintaining this control file commonly for all these pluggable databases, application containers and all. SP file also we are going to maintaining separately. I'll tell you those things. Now we can go ahead and see what is multi-tenant architecture. So this multi-tenant architecture will enable you the container database, like single database or single software, install software once and configure n number of databases. What is mean by the CDB? It includes 0 or more pluggable databases. The container database is nothing but the original or what I can say holds the complete information related to the custom pluggable databases if you want to create any pluggable databases. And PDB is a portable collection of schemas, schema objects, non-schema objects. All these together, we call it as a PDB. This multi-tenant architecture has been introduced from the 12C onwards, but we have an option whether you want to go with non-multi-tenant or multi-tenant. I will give you one direct like Oracle Metalink ID or Oracle database. Okay. See, multi-tenant architecture will resolve the so many problems. Okay. The problem is nothing but the maintenance cost, resource cost, and other things. We can see this multi-tenant CDB, the same thing, whatever the definition. Container is a logical. If you want to go with the definition, I'll give you that. Container is a logical collection of data or metadata within a multi-tenant architecture. That is the definition. Or if you want to go with the CDB, what is mean by the CDB? Simply the same architecture, whatever I have given the diagram. So we are having single container, multiple pluggable databases and application roots. CDB root is a collection of schema, schema object, non-schema objects. Why? Because very simple, guys. Whatever the schemas are objects, all objects, right? If you want to create a user, if you want to create a table space, you require all these things. System, sysocs, those databases like sysocs is a table space, sys and system is a users or schemas. So schemas and schema objects, non-schema objects, everything is together we placed into CDB. If the CDB is corrupted, you cannot able to manage your PDBs. That is simple. Okay. It's a system container is nothing but the exactly container like this one. This whole portion we call it as a system container. It holds one CDB root, one PDB seed, and remaining all these pluggable databases. For theoretical purpose, we are talking this much of thing. If simple layman language, if I want to talk, what is difference between multi-tenant and non-multi-tenant? Simply you can say non-multi-tenant, we are managing SID and databases. There is no CDB and PDB concept. But multi-tenant, we are managing instance plus CDB, PDB model. So in these databases, single instance, single database we are managing. If you want to manage two instances, single database, we call it as a rack architecture. Okay, generally high availability purpose. But here you can manage single instance, n number of databases. But here we are not going to talk about the rack. But if you want to enable the rack, you can create another server, there install the instance. And whatever the CDBs and PDBs you are going to manage, you can manage with the rack, high availability purpose. Whatever we talked till now, there is no high availability, right? Single server, multiple pluggable databases. That is one disadvantage, right? If you are going to install 30 databases in single server, if the server OS level is crashed, you cannot able to access all the 30 pluggable databases or databases. That is huge drawback. But right, as of now, whatever we are going to use high availability software which is provided by the Oracle, they will highly recommended to go for high availability architecture when you are using multi-tenant thing. So in that case, two instances, multiple pluggable databases. Here we are using single database only, single database, multiple instances. But in CDB, multiple databases accessing from the multiple instances. Why? Because the container or multi-tenant architecture itself, the architecture is going to design in that way, right? So we can able to access. Here, services will be taking care of the huge role. What is meant by the service? Service is to identify which user is going to connect, from which server the user request is coming. Okay, 30 databases is there. Okay, DB1, DB2, DB3. So how we can distinguish, how we are going to provide the connectivity to users, how they are going to connect with individual databases. We are going to provide each database one service name, that by using that service name, users can able to connect to those individual databases or pluggable databases. I'll show you that as part of our lab. Without the service name, users cannot able to connect it, right? This one, we are having n number of pluggable databases. If the user is connecting to this pluggable database, this should have an identical name. That identical name we can keep it as service name differently. This should have different name to connect. Even though it's a pluggable database, PDB1, PDB2, PDB3, the PDB1 is a service name, PDB2 is a service name. Based upon that service name, users can able to access individual PDBs. Yep, that is high level, guys. And for the theoretical part only, we are going to talk. What exactly the PDBs holds? The PDB contains the data and code required for specific set of features. Simply, it's a business related thing, like individual, whatever the thing which we are going to manage, each PDB holds its own business data. Simple example, this PDB we are going to maintain it here. This will store set of data which is related to whatever the business we are going to provide, that business, specific business data. And this is also, suppose if I can say this is a HR database, all HR related information. HR means whatever the HR is going to maintain, payroll or invoices related things and other things. This is for sales. Sales team, what are all the sales they are going to perform, and that information is going to store into this database. And this we can take it as an employee to apply leaves or taking the leaves or your hikes or other performance metrics. All those things will store into this database. In that way, individually, we can maintain the databases. Each business specific data, right? Business specific data is going to hold into your PDBs. But CDB, it's a commonly store all the schemas, system level information, like all your schemas and all those things. Now, it is not specific business, right? It is a commonly stored all the information. CDB, it's a logical information. Logical collection of data or metadata. Metadata means the software level, right? Whatever we have installed, that software related information is stored in your CDB database. But pluggable database, it holds the specific set of features or specific business needs data. It will be stored. It is not specific to common data. It is specific pluggable database related information. Okay. So if I want to talk about a specific thing, a container is a logical collection of data or metadata. This we already gone through it. CDB root, the collection of schema objects, non-schema objects with which are all PDB belongings to. Like if you create a schema or user in CDB root level, CDB level, that schema can able to connect your pluggable databases also. If you're having 10 pluggable databases into your database, you can able to connect all the pluggable databases. That information commonly stored into your CDB root. Okay, and all the metadata and other things it is going to store it. This one. I'll show you this diagram now to understanding purpose. See, even though in multi-tenant architecture, instance is common. Whatever non-multi-tenant architecture, how our instance is going to see if your SGA, SGA is holding memory, right? That memory is going to assign over all the PDBs, the same SGA. We are not going to maintain individual SGA for individual PDB. If you are maintaining 10 pluggable databases in single instance, so 10 pluggable databases can share the single this PDB memory only. Background processes are same. We are not going to different background processes. We are having same background processes. But here the structure is going to change. So this is our CDB root, or this we call it as complete container. Container is nothing but the whole the system, complete system level information. Inside of the container, we are having CDB root and PDBs. Okay. This is not the CDB seed, it is a PDB seed. PDB, there is no CDB seed and all, PDB seed. What is mean by the PDB seed? PDB seed is nothing but, PDB seed is nothing but, it is a seed. By using this, we can create n number of pluggable databases, PDBs. Without this, we cannot create pluggable databases in our container. In our container database, under CDB root, we cannot create pluggable databases. This is always read-only mode only. This PDB seed, this is not a CDB seed, this is a PDB seed, always read-only mode. I'll show you that also. Remaining things, this is our sales related pluggable database and it's our HR related. If you want to maintain and so on up to 256 or more than 256 pluggable databases, you can maintain. See, this CDB root, it holds system, sysocs, undo, temp, its own table spaces. PDB seed also, it holds its own table space, system, undo, sysocs, tempo, all its own table spaces. And data files, this one, sales PDB, it holds its own system sysocs, system table space, sysocs, undo, temp, and user table spaces extra. If that want, it can maintain its own custom table spaces or user table spaces or other things. But commonly, what are all the common files in our multi-tenant architecture? Control files and redo log files are common to all the pluggable databases. These control file we can maintain commonly. By using this control file, we can mount these databases. Without this control file, we cannot mount our database. What are all the system table spaces, individual to system, undo, sysocs, temp table spaces is there. All this information is stored into your control file. Redo log files also, these are commonly, these are not PDB or CDB specific. It is common for all CDBs and PDBs. In our multi-tenant architecture, this is one important interview question, or for your information, you can remember these two are the non-shared. Okay, non-shared. Anyway, our instance is separate, one instance only for all these things. So we have specific P file or SP file. This is common. By using this SP file or P file, we can put our data instance in no mount state. By using this control file, we can put our database in mount stage and then we can open it. So control files, redo log files, SP parameter files are the common for all CDBs and PDBs. And individual system table space, sysocs, undo, temp, these are CDB, PDB level. Individual CDB level and individual PDB level tables will be there. That's where we are going to see so many data files and so many system table spaces. I'll show you those things, guys. Okay. This is our, what exactly it holds, right? Single database shares. Our multi-tenant is going to share background processes, shared memory process or SGA, memory, system memory. Metadata is going to share all PDBs and CDBs, same metadata. Redo log files are shared. Undo table space also we are going to make a share, but yeah, individually also you can maintain. Individual undo table space we can maintain. There is no issue. This one, if you want to keep all together one undo, you can maintain, but we can share the undo individually also. Control files we can share. This we have an option. If you want to maintain individually or if you want to maintain commonly. But these are all non-shared, like non-common. It's not a specific PDB or CDB. It's a shared one completely. That is only one thing, guys. See here, CDB container database. Container database holds your CDB root, PDB seed, and n number of pluggable databases. That's it. That is our multi-tenant architecture. But we did not talk about this one, right? Application container in this way. Let me talk about this. Containers in CDB, how it is going to this said just before we gone through it. A common user in a database, whatever you are going to create a user in CDB level, that user we call it as a common user. That user prefix is C hash hash. User prefix. And root container name as CDB root. That is already there. This is our CDB root. The system container, the CDB holds one root container, one PDB seed, not the CDB, PDB seed, and 0 or more pluggable databases. It's a logical container. Like whatever you are going to talk about container, that container is a logical portion. We cannot able to see it, but CDB root and these things we can able to see it physically. Okay, I'll show you that. Application container consists exactly one application root. And inside of that application root, we can create n number of pluggable databases. Again, application container includes only the PDBs plugged into this application container. We'll see that. What is mean by that? And yeah, 1 second. Okay, this architecture we can say without application and with the application. How it is going to? So no application, multi-tenant with no application container. We have the container databases. We are having one CDB root, one PDB seed, and number of PDBs. There is no application root or application related things. This is one thing. With application, the architecture is going to change. This one. We have one CDB root, we have PDB seed, and we have PDBs. If you want to configure a number of PDBs, you can configure. There is no limit. Okay. Not limit means up to 256 or more than that it is there, but not those huge like 5,000 some other thing. Number is there, but not unlimited. We have a huge number. But this application root is going to, we can install this application root in multi-tenant architecture. Under this application root, we can create again PDB seed and PDBs, n number of PDBs. This is different. Somewhere, if you want to use a specific business related things, you can use it. But I haven't used till now this application root related things in my tenure. Okay, I used these things. Container database without application architecture. With application, we are having. Even you couldn't able to heard much from this application container in social media or other sites as well. But yeah, we have an option. We just want to know it. If somebody will ask you, we should not put our face as a blank, right? That's where the same kind of scenario, how the CDB and PDB model is works. This is also similar kind of one. We can able to use it. For all these things, single instance only we are going to maintain. There is no difference at all. Yeah, now we can go ahead and then see the challenges. Actually, these challenges we already discussed a few minutes before. Now again, non-multi-tenant architecture challenges. So these are all the server 1, 2, 3, 4, 5, 6, 7, and so on. These many servers, each server shows individual databases. Individual, one server belongs to one database. And we required 4 DBAs to manage all these databases. But in case of multi-tenant, all these together we make it in under one CDB, one container database. All 10 databases, we are going to plug it one CDB root. If you want to shut down and start up, if you want to apply the patches, one DBA is sufficient. One DBA is sufficient. No need to go for multiple DBAs. One DBA is sufficient. But in case of this, we need to maintain extra. And one head is required to monitor these 4 DBAs. And each database is required at least 10% we are going to maintain the buffer. In case of these many like 11 databases is 11 into 10, like around 1 TB of the storage or other things is going to wastage or ideal. That much of storage, if you want to purchase huge number of amount they have to invest, right? That is also going to save in our CDB PDB model. Maintenance is easy and resource also very less resource we can maintain. That's the main use cases. Thousands of databases, generally hundreds and thousands of databases in your organization you're going to maintain. Thousands and hundreds of servers you need to purchase and you need to install. But in case of multi-tenant, we can achieve in a few servers, hundreds of databases, we can manage it with high availability. That is also possible. Place multiple databases on each server. We need to place it in non-CDB related things. Same thing, whatever we are going to use. So that is only one differences. But the benefits of our multi-tenant architecture, keep one container database, all your 11 or 12 or how many hundreds of databases into this pluggable and then manage it. So we can manage one or two databases admins all together. It's very easy, right? We can save the cost wise. Maintenance also is very easy. Cost reduction is possible. Easier and more rapid movement of the data code, easy management and monitoring the physical database, securing the separate administration tasks, performance tuning also it's very easy to manage it. Patches and upgrades also very easy to go with. And clone also, if I want, I can add patches. Clone also it's very easy if you are in a multi-tenant architecture. Upgrades with these things are very flexible if you are going with a multi-tenant architecture. These are all the benefits of your multi-tenant architecture. Do you have any questions still now?
No.
Okay. Now we can go ahead and see it, how we can distinguish, how to find whether my database is multi-tenant or non-multi-tenant. I'll show you this here. SQL plus as SDBA. I connected to my thing. See here, if we can show that PDBs, it is going to show PDB seed. It's always read-only mode and one PDB. If you want to create a number of PDBs, we can create it in a single database. But in case of non-multi-tenant, this is our non-multi-tenant architecture. Let me check our database is up and running now. Okay. Let me set the Vara environment. Database is not running. ASM only running on this instance. Okay. SRVCTL status database IFND back stable or INV RAX DB1. See, tracks node. Okay. Node 2 is running, node 1 is not running. Start. Instance -I RAX DB1. Remove the D thing, and then we are going to start this instance individually. Might be I have stopped the cluster disabled. I might be disabled the cluster. That's where it is going to not going to start this thing. RAX DB2 is going to working perfectly. If I want to take that, I can take 22 Oracle. Here we can able to see it. Yeah, even though I have started here. Status database. Yeah, now it is running. Now I will connect to my SQL plus access DBA. See, this is my non-PDBs one, non-multi-tenant architecture. If I can ask show PDBs, there is no PDBs. It is non-pluggable database. But in this case, if I can give show PDBs, it is going to show this. This is a multi-tenant architecture. In this way, we are going to distinguish. Here, if you want to see, select, let me clear it and then we can, okay. Select data files, all my data files I want to see, db underscore data underscore files. Select file name, comma, table space name from db underscore data files. Set lines 200, call format a 65. Done. So these are all my data files it stores in our ASM system. That is fine. But in case if I can give the same command, let me give this set lines. Let me format. Same query in multi-tenant. How many data files I used to get? How many table spaces I used to get? Let me check. See here. How many system table spaces we are having? How many sysocs table spaces we are having? In physical level, I'll show you. Okay, here it is going to show it CDB level. Okay, it is going to show it in your CDB root table spaces. But really, if you want to see how many system and how many files we are having, I can show you here. See these many files. We have PDB2 is there, test PDB is there, PDB1 is there, PDB seed is there. These are all the pluggable databases. In case I'm having, in this scenario, I'm having three pluggable databases and one PDB seed is there. But these two I might delete it. That's where it is not going to show it here. It is showing only one PDB1. Only this PDB1 it is showing. But I have physical files exist, but I may deleted those things logically. Physically, the files will be executed. That is different scenario. And yeah, I want to show you these things. These are all our, whatever the files it is there, these are all related to your CDB root files. I'll give you the diagram so that you can understand. See here. What are all the files I'm going to show it here? These files are these system table space, sysocs, undo, users, and custom. These are all the custom table spaces. All these table spaces belongings to your CDB root. This one. If you want to see these files, I can show you. And this PDB, like PDB1 and PDB2 we are having. Right? Individual also we should have system, sysocs, undo table spaces. Let me show you those. How should I find? This is related to your CDB root information. And I have this pluggable and CDB things is there. Let me go to, okay. I'll show you physically so that we can go other things. See here, for PDB1, I have again my system table spaces and all these table spaces I'm having. And PDB2, if I can go, there is no PDB level table spaces. Why? Because as I said, I may delete it. The structure is there, but the files is not going to exist in PDB2. And one more is there, test PDB or something I saw, right? Test PDB. Here also I don't think, yeah, test is there. Okay, this could be a backup file. Nothing. This could be a backup one. So as of now, we are having one CDB, one PDB, remove FNRF, this one, and this one is, we don't have any data inside of these two folders. That's where unnecessarily we should not keep. So one CDB root, all these files are belonging to your CDB root, and your redo log files and control files are common for all CDBs and PDBs. But this PDBs holds separate system and other sysocs table spaces. This PDB seed also it holds. Let me take PDB seed. This is also its whole set of sysocs, system, temp, undo table space. PDB seed also it holds their set of files. CDB root also it holds set of files, and PDB1 also it holds its individual system, sysocs, temp, undo table spaces. These are all physically we can see it. Logically, how we are going to see it, I'll show you. Show con underscore name. This will show you whether which you connected with PDB or CDB root, which container you connected, how to find. How many pluggable databases you are having in this architecture, you can see this command. Okay, this one will show you which container you connected, that you can able to see it by using this show command. Okay, now I am in CDB root. I want to go to pluggable database. How to go? Alter pluggable database. Alter, okay, not the alter session set container. This is the command to use. Alter session set container, alter sessions. Okay, okay, no problem. Container equal to PDB1. Single code we don't need to mention, that's fine. Now we can see the same thing, show con underscore name. Earlier, whenever you are there into CDB root level, it shows CDB root we are in. But after I changed my container from CDB root to PDB1 location, it is showing PDB1. I'm in PDB1 now. If I can query this thing, table spaces query, what is this? Why it is not going to? It will show you your all the data files related to your PDB1. This is your PDB table spaces. PDB1 table spaces. Undo. PDB1 sysocs table space. PDB1 system table space. But earlier we saw here direct table spaces, right? We couldn't see anything related to PDB, and directly it is showing like test. There is no PDB folder, right? If it is there in PDB1, that is PDB files. If it is not there, that is CDB root one. That is only one thing which we need to identify. In this way, we are going to see it. How many data files, how many system table spaces or individual system table spaces, if you want to see in your thing, you can able to see it by using this command. And one more thing, how to start and stop your pluggable databases. Okay, you can use shut immediate once you are in a container level. This container level, we are in PDB level. If you want to stop this only PDB, not the CDB, you can use shut immediate. So it will close your pluggable database only. It won't stop your this thing container CDB root. That will not stop that. Individual PDB we have stopped it. Now, if I want to go back to my CDB root, you can use alter systems. I mean alter session set container. You can use CDB root. I have connected back to my CDB. Now you can see it which one you have connected. Your container is now you are in CDB root. Now you can see show PDBs. PDB1 it is going to show it, but what status it is going to store showing mounted. By default, all pluggable database in mount state. If you keep this read write mode, put your open mode is read write, then only users can able to connect to these pluggable databases. Only one thing here you need to understand is in normal databases, non-multi-tenant architecture, if you can see this background process, it is saying your database is up and instance is up and running. Most of the cases, your database is also up and running. There is no issue if you can see this thing. But in multi-tenant architecture, what will happen? If I can query ps-ef pipe smon, my instance it is showing up only, but internally my PDB is mounted. It is not read write mode. Users will send you the mail, hey, DB, I'm unable to connect to the database. They don't know which pluggable and other things. They will say that I'm unable to connect to the test instance. You are directly go ahead and see this PSMON background process. You can see, oh, it is up and running. You can say my database is up and running. Can you check again? That is a conflict, right? But as part of multi-tenant architecture, you can see the instance status, and also you can connect to the SQL Plus as a SysDB and check for this. So PDBs, the PDB1 status should be read write. And one more thing, if it is a read write mode only, still they are saying they are unable to connect it. What you need to find out is here the status, very, very important. If it is a read write, restricted equal to yes. If yes is there, users cannot able to connect to this database, even though database is read write mode. This portion you need to check. Those many prerequisites will be there as part of our multi-tenant architecture. That as part of our clones and other previous sessions, we can see how we can avoid this restricted mode as to no. Generally, the restricted mode should be no default value. If it is a yes, means there is some issue. The compatibility in between your CDB and PDB is not in compatible. CDB and PDB, there could be some patch level issues or there could be some other issues. These two are not in sync. These two are not in sync. At that time, it is going to in restricted mode. So we need to do in a different scenarios. What will happen when your status of the PDB is restricted equal to yes? Users cannot able to connect it. There is no use even though if it is a read write mode. If it is a mount state, you can start it. If it is a restricted mode, you can check the log files, alert log files and other things. Then you can make sure the restricted should off no. Okay, we can see it in future, the troubleshooting part. But you have to understand this architecture, how you are going to see the status. That's okay. Now I have stopped. This is a mount state, right? If I want to start this pluggable database, how I can start? Normally we are using shutdown startup, right? No, here you can use, you can connect this pluggable database, use the startup, it will work. I'll show you that also. Alter session set container equal to PDB1 startup. This also it will work. Your pluggable database is going to start up. Let me show you how the status is going to show PDBs. See, it is in read write mode, restricted mode is no. In that way also we can use it. Once you connect to the pluggable database, and then you can use shutdown startup individually. But it is recommended if you are having 100 pluggable databases, how you are going to manage? If it is a single pluggable database, you are going to manage within a minute. But in case of if you are having 100 pluggable databases, can you go on individually one-on-one database and then shut down and start up? It is very difficult, right? That's where we have another option. Alter pluggable database name, close. So this is the command to stop your pluggable database. It is read write to, I have closed it, it is done. If you are using multiple pluggable databases, same alter pluggable databases, close all. You can give that. Close all close. That I'll comment, I'll give you. Open all. Every the container databases we can able to make it alter pluggable databases one. Let me give you that command. So individually we can do it, or see here clone document. That is fine. So in this way, you can give. Give me 1 second, guys. We have so many commands. That's okay. Simply, we can go ahead, close all, open all. That command, I can use it. So as of now, if you want to start this pluggable database, we are having only one. In future, we are going to take 2 pluggable databases and we can use that command. Okay. Pluggable database, open. This command, we can able to start our pluggable database. Rewrite mode. You can use close all command also. If you have multiple, then only we can able to see it. That's okay. Close all close. It is the command to close all the pluggable databases at one command. This PDB is always in read-only mode. If you are having PDB 1, 2, 3, 4, and so on, 10, 100, those all will be closed. If you want to open all, open. Reverse, this is all open. Close all, open all. Sorry, all open, only one difference that is. That is the command where we are going to use it, or pluggable data. It's read write, right? In this way, you are having 100 pluggable databases also. We can close in one command by using single command, and you can start single command to all pluggable database. It is going to start. Or else we have another option also. If you are having pluggable databases individually, you can give, I'll give you this, alter pluggable database 1, PDB2, PDB3, open. If we are having, you can use this command separated by the comma, use these pluggable databases, and you can open it and close it. That is also unpassable. So these are all the commands where we are going to manage our pluggable databases. Okay, shutdown startup also it will work, but that is very difficult if you are using multiple things. If you are using this thing, you can able to see it. Let me clear all these things. I'll share this file for practice purpose. You can practice it for your end. Yeah, these are all fine. And what else as part of this maintenance? That's a major thing, how we are going to start and stop our pluggable database. This is the high level architecture, guys. For normal databases, how we are going to manage? Using SQL plus as sysdba, shut immediate and startup, right? To shut down on startup. But in case of multi-tenant, you can use it. But on one more thing, guys, can't I stop all these things with shut immediate command? You can do it. Show PDBs, including CDB also. We saw how to stop the pluggable databases. Now we need to stop the CDB root also, right? Shut immediate. If you do this from the container database, CDB root level, it will stop your PDBs and it will stop your CDB root. And it is going to dismount your this thing. Instance also it is going to no mount. Instance is closed, dismounted, and it is going to stop your instance, shut down instance completely. This is the not recommend, what I can say, how when you are going to do this shut immediate option from your root container, CDB root. As of now, Oracle is not available. That's where it is not going to read the container one. So we will get some pluggable violation errors when you are not going to proper shutdown and startup. In your multi-tenant architecture, what is the shutdown approach is? You have to stop your PDBs. Stop PDB first, then stop CDB root. Okay, and starting order, reverse order. This is the stopping order. Starting order, it is the you need to start the container and restart the PDBs. Generally, sometime if you are not going to do that, your CDB, when you use the startup, this will automatically start your pluggable databases. Better and good practices, you have to start and stop orderly. Pluggable database should be stopped first, then only your CDB root. Show PDBs. See, it's automatically up as part of your complete startup and shutdown thing. But it is not a good practice. You have to stop first pluggable database. LUGG pluggable database. PDB1. Close. Once it is down, you can take a confirmation. It should be in mount stage. Then shut immediate. we need to stop the CDB route. Okay, our container. That is the better approach. Don't go with directly shut immediate. It is not a good practice. Even though it is going to stop your PDB, it is not a good practice. In case we are having, I mean, in this case, we are having one PDB, but in real time, you might have 50 PDBs or 100 PDBs. If you are using shut immediate directly without stopping the pluggable databases, it is going to escalate. And also, it is not a proper way. There could be a conflicts. Startup. And we can see this, how the status is going to change. See, even though we are going to start up, it is going to internally read the pluggable database and is going to start up the pluggable databases. Okay. But we have to go with in this way, stop the pluggable database, and then only we are going to do these things. If it is not started, even though after you have start up the CDB, you can start manually. Mostly it will start. A very rare case, we need to look into it and then we need to start it. Okay, let me give you this also. Yeah, guys, these are all about our CDB, PDB architecture. Any doubts? Otherwise, we can close for the day.